Good evening, good night, gentlemen. Welcome. Alright, so continuing from where we left off, we were on the constructing a cycloid in AutoCAD, right? Now we constructed our cycloid from the instructions that were given here, and we made this one and did our labeling, right? So for the labeling, what I did was to use a diameter or radius measurement and then explode it and edit it, meaning let me see where I can find one of those. Like here, where you have your dimensions from here, you get a diameter or radius, click on the circle, it forms the dimension, but then I'll explode this by clicking explode here, and then I can double click and edit it and write whatever I want there. So whatever. Good. Now that's how you edit, and you move this to behind the arrow. If you haven't already known, if you don't know already how to set up your dimensions, I will teach you that in the following classes, right? But for now, we'll be doing our epi and hypocycloids. Now, the epicycloid, like the epidermis of your skin, is the outer one, the one on the outside of the base circle. Notice here, this one is a flat line, right? But the epicycloid and the hypocycloid is the rolling circle. Instead of rolling on the flat line from x to y, it is now rolling on the outside of another circle, or diameter, outside diameter of a circle, or the inside circumference of a circle. So this is the outside of another circle, and this is the inside of another circle, and the rolling circle is in contact with this circle here. So the base circle is inside here, and the base circle is outside for the hypo. So epi, base circle is inside, hypo, base circle is outside, and vice versa, because the rolling circle is on the base circle here, and the rolling circle is inside the base circle here. Alright, so this is an epicycloid, hypocycloid, and the difference between the procedures for this one and these would have to be that this line, instead of having them straight, all the lines are coming from a central point now, which is a center point, and this is the center of this base circle here, as well as the center of all of these radiating lines. Similarly here, the center of this base circle, same center of all the other lines. So the procedures are the same. You draw your base circle, which is the diameter of this one here, or the diameter of this one here, radius, whatever the diameter radius of this base circle is, you draw the base circle first, then you attach your rolling circle to it at point P, then you divide your rolling circle into 12, then lay out the circumference of your base circle, of your rolling circle on the base circle. So here we roll the circumference along the straight line, here we'll roll the circumference from point P all the way to point 11. Similarly here, from point P all the way to point 11. 12 divisions, just the same. What you do is basically, if you know, you can work out, if you know what the distance between here and here is, then you can always work out the distance between the rest of these divisions. So what I normally do is to basically offset or to divide the length of the diameter into find the length of the radius, the circumference, the length of the circumference, or the circumference of the circle, and then you can get the maximum distance and then divide that arc into 12. So we'll figure it out as we go along. It's a little confusing, but as I was saying, the major difference is the center line. In the flat one, you can realize that the center line C1, C2, C3, C4, C5 going all the way to C12 is between 9 and 3 because it's coming from the center of the circle. However, it passes through 3, right? Because it's straight. On these ones, the difference is it comes from the center of the circle and does not pass through 3 or 9, because 3 or 9 has a curve in it and it goes above right here and comes back to 3 here and goes around. So the center lines are different for these ones because they are on an angle and they are circular. So the centers are different. This is the center line above number 3, and this is the center line here. So the center line is where you radiate all your circles from. So all these circles are you get the arcs that cut the particular lines from the center. So from the center line, using the radius of the circle, and scribe on each line. So you put that center one, open to the radius of the circle, put that center one, and scribe on line 1. Put that center 2, which is here, scribe on line 2. Put that center 3, scribe on line 3. Put that center 3 here, center 3, scribe here, center 4, scribe here, center 5, scribe here, center 6, scribe at the peak, center 7, scribe on 7, line 5 and 7 are the same. Notice 5, 7, they both pass through the same point. So 5 line on the other side, 7, 8, scribe on 8, 9, scribe on 9, 10, scribe on 10, 11, scribe on 11, and it meets at 12. So that's what you do. You plot the points. From center 1, scribe on line 1. Center 2, scribe on line 2. Center 3, scribe on line 3. Center 4, scribe on line 4, using the radius of the rolling circle. I hope you understand that. Now, we'll start by finding what we need to draw this. So we look in the instructions in our book to find what the dimensions, the given dimensions are. So it says here, for the epi and hypocycloid, right? We're just going to snip this so we can have it within our drawing space. It says for the epi and hypocycloid, the epicycloid rolls on the outside of the circle and the hypocycloid rolls on the inside of the circle. The construction is similar to the cycloid except that the angle phi must be calculated, right? If the diameter of the base circle is 180 millimeters and the diameter of the rolling circle is 60 millimeters, the formula can be used to find the angle, right? So I say phi is equal to 360 times diameter of this sine is diameter, this sine is phi for angle. So diameter of rolling circle over diameter of base circle. So the diameter of the rolling circle is 60 and the diameter of the base circle is 180. So when you divide it, you get 120. So you know exactly what the angle should be between this point and this point. So phi would be 120 degrees here and here, right? So from this point, you just draw 120, boom, and then divide between this space and this space into 12. And you get it. All right. So angle phi of 120 degrees can be marked off and 12 divisions of 10 degrees, because 120 equal 10, right? So every 10 degrees you have a line can be marked to give points C1, C2, etc. going all the way to C12. The procedure is then given as the same for the cycloid. The procedure is then the same for the cycloid. So the same procedure used for the cycloid is the same procedure used in here. The only difference is that you're using this angle. As I mentioned, the center line might be a little bit different and the angle that you're drawing on. So the base circle is 60, is 180 in diameter, and the rolling circle is 60 in diameter, meaning the radius is 30 and the radius is 90. So let's go. Start by the base circle. So the base circle is diameter, so it's 90. Enter 90 radius give you 180. Okay, so 90 radius give you 180 diameter. That is the base circle. Should draw it. Hold on. Start from the center lines. Turn on ortho. Start with the center lines. Straight in per second. Alright, start again. So 90. So 180 diameter. Good. So use 90 if you use radius circle. If you use diameter circle, use 120. Thank you very much for your kind cooperation. Alright. That's the base circle, which is this one here. You only go use a part of it. Now you want to form the this one, which is the rolling circle. The rolling circle is 30. So we are going to have it on an angle of, so based on how this looks, this is 120, right? And angles on a straight line is 180. So you'd have to have a particular angle here and here to get the 120 in there. And that would have to be 30 on this side, 30 on that side. If you do the maths, look at it. Angles on a straight line is 180. Boom, we have a straight line below this point here. So the angle on this straight line is 180. And you have a portion here and a portion there. So you can basically start drawing it from here, but you just stop somewhere here. So you'd have a 60 over here. So the 120 plus 60 give you 180. Or you can have 30 on this side and 30 on this side and have 120 in the middle. So we'll do it like it shows here and have 30 on both sides. So turn on ortho, not ortho, polar tracking, make sure you're on degrees, and then go ahead and get your 30-degree angle. So that's 20, that's 30, boom, 1. That's 260, 250, we're trying to get 150. 150 degrees, okay, that's good. 150, 180 minus 30, 150. Alright, so we have the 120 between here. We can measure it and see that we have 120 between these lines. So angle between that and that gives you 120. Alright, good. Now you want to draw your rolling circle, which is which should be 30, right? So diameter 30, diameter 60, radius 30, enter. And we pull this above, move, enter from this point to this point. Alright, so the rolling circle is there. From the center we want to form. So let's change this to angles of. Alright, let's divide this into 12 now. So dividing this into 12, divide. In 12 segments, enter. There you go. So we can connect all of them now. Alright, so when we divide that now, we want to divide this, but we have to trim it first. TR, enter, boom, and trim that. Now we can divide this curve into 12 to get the same amount as this. So divide, divide, select that, 12, enter. Now we can draw all of the lines through these to these points and then upwards afterwards. So we can extend them afterwards. The reason being, if you try to Jaja, I'm gonna do this again because I made a mistake here, I think. I made a error here. Notice it's away from the center, so I have to go back a little bit. So let's revert a lot. Alright, so from there I can move this all the way over to here. Right in the center there, good. And we're still good. Alright, so trim, TR, enter. Now I can get rid of this one here. Then I can divide this into 12. So divide, select 12, enter. You can radiate your lines from the center point. If you try to draw it through there, it was not connect, right? Sometimes it will get off. So what you want to do is connect it here first and then extend it up to the maximum point. So keep drawing lines, radiating from this point. Always try to get your center point correct. Alright. If you don't see this box, you know you're not in the center, right? So if you're seeing that shape, you know you're off. So box to center, right? When you reach a point, this is a circle. Trying to get it in the circle, right? All of these affect accuracy, so you want to get it exact, perfect. Sometimes, like that, it says an intersection, but it's not accurate if you check it, right? So you want it to be in that circle there. Do all you can to ensure accuracy. Alright, so now we want to draw another circle that's on the top of this one, so we can extend all these lines. So next thing we're going to do is extend all these lines from each point. So normally what we do is radiate lines from each point on this rolling circle, like here. We radiate lines through 7, through 6, through 5, through 8 and 4, through 9 and 3, through 10. So what we're going to do now, instead of drawing straight lines, we're going to draw curved lines or circles then. So from the same center, circle, click there, and go to line 1. Then enter, circle, line 2. And there, circle, line 3. And then here, circle, and the center line is different from line 3 and 9 as I explained before. So you want to click to the center now. Boom. Next one to line. Boom. Next one to line. Boom. The next one to line 2. That's here. There you go. Now you can trim and get rid of all the extra lines. Alright. So there we go. So now we can extend these lines all the way up here, just like this one here. EX, enter, and you can click all the lines that you want to extend. There we go. So we have all the lines there now. So what we should do now is to mark our center line to be a little bit different. Mark it as center lines, right? Change the line type scale to about 10. Anything that allows you to see it visibly, that like a center line, good. And that's it. So from there now we can copy the circle and mark each point. So what we normally do is you can use scribe to use an arc to scribe. So arc, center, start, end. Click center 1, so line 1, center 1 right there on the center line. Go to line 1 here, and you want to scribe on line 1. This is line 1 and line 11 at the same time. So you want the radius of this to be 30, and you want to start scribing there. Boom. So you can do that as a means of marking your points, or you can just use the circle all around. So I'll use this one for now. So I'll change my line type to hidden line so you can see it more visibly. Change this to hidden 2. Alright, so that's the first arc. So next arc again, center, start, end. The center 1, so go to center 2 right there. Come down to line 2, which is here. And so I scribe from 25, is 25, 25, 30. Enter. Draw right there, cutting that one. Good. Then we'll do the same thing again. Center 1, center 2, center 2, center 3. So go line 3 here. So 30, enter. Scribe here. Oh, have to select center, start, end each time. It's a lot of work. Okay, so center line 3. Scribe from 30. Enter. Come around like that. Cut it. Boom. So you notice you cut line 1, cut line 2, cut line 3. Line 1, 2, 3, 4, 5, 6. Alright. So 1 is 1 and 11, 2 is 2 and 10, 3 is 9 and 3, 4 is 4 and 8, 5 is 7 and 5, and 6 is peak, and here is 0, 0 to 6. Alright, good. I hope you're understanding. I really hope you do. You are understanding. Alright, so the next step, center, start, end again. Center 3, 1, 2, 3, no, center 4, 30, scribe on line 4. Well, I made that one too far down, so let's start again. Center, start, end, center 4, scribe on line 4. Oh man. Alright. Cook it. Don't do that at all. Alright, now same thing for 1, 2, 1, 2, 3, 4, 5. Center 5. Grab on line 5. Man. 5, good. Then center 6, center 1, 2, 3, 4, 5. Center 6 is here. Alright, the center 6. Square 1 line 6. 30, enter. See, right in the peak. 6 gives you right in the peak. And then you do the same thing all the way over to 12. So start going down the other side now. So from 7, square 1 line 7 by 30, enter. Ooh, right here. Then next thing, center start end. So 6, 7, 8, square 1 line 8. This one right here. Thank you. So now we have center start end. Center 6, 7, 8, center 9. Square 1 line 9, which is the same as line 3. So it's 30. Boom. 10, 11, 12. So 10. Center 10 now. So 10. Square 1 line 10. The same as line 2. 30. Enter. So 30, what we type in is the radius of the circle. The reason why we type 30 each time is the radius of the circle, right? Because the rolling circle is 60. Alright, so the last one now, which is center 11. Center 11, center start end. Center 11. We scribe 30. Radius, enter. Scribe there. And then from here to here. Boom. So now we want to use spline to form our shape. SPL, enter. And we start from 0 to 1 to 2. Oh my, let's do that again. SPL spline from 0 to 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8 to 9 to 9 right here. Right, thank you. The red line is center line. To 10 to 11 and to 12 right there. And that's you. Your epicycloid is complete. Now you want to do your labeling as usual, your lettering and all of that. Labeling and lettering. Alright. So your center line, your construction lines, everything is great. You can delete these extra ones. Now just like we did with this one, we label all our points going forward, right? That's the same thing we want to do with this one. We want to label all our points just like we're given. Just like we have been given in technical drawing book 1. Right? So all these points will be labeled. All of this will be labeled. All of this, the rolling direction of the rolling circle, all of that should be there. Right? You can always draw a curve, then draw an arrowhead on the curve. Or an arc, then draw the arrowhead on the arc. Figure it out. Alright, so we can copy this. Paste it on the rolling circle here. Caps, all caps all the time in engineering drawing. Let's change all of these to object lines, one circle, and the base circle also. Can use this as a thinner line like this one for now, and that one for now. Use these for now, right? just so they have different in colors. They are not. They are all construction lines. The circle is a little bit thicker, but the only thing that should be right really is the cycloid. These are mid types of lines, like not too bold but mid range. These are constructions, and then they have the center lines. All right, but I can change the properties of these from to bilayer, which is there right now. I can change the thickness right here in properties, so it doesn't change the full layer but it just changes for this one. So I change to 0.54, so it has a little greater thickness, and it is a continuous line now. Similarly for this one, I can do the same thing. I can change the properties to 0.4, just so it doesn't compete with the thickness of the cycloid itself. And change the color to blue if I want, or yellow, or whatever. So you can edit properties there. The reason why I don't use blue often is because the blue is hard to see. So blue is not very visible, right? Select similar, and you can change the colors to a more visible color like green, cyan, blue, magenta, like magenta. So you're aware of two methods. Method. You're aware of two methods now. So you can use the center start end arc to form the points, or you can use the circle. I think the circles are more confusing, so I'd recommend this one. But whatever works for you, you have the freedom to choose. Freedom to choose. Right. Alright, now that we have completed this one, I'm going to do my labeling. You should do the same. So that's it for that one.